Alright, good morning. This is lesson 26 for Integrated Math 1. We're going to be understanding relations and functions, and we're going to be able to evaluate functions. If you look down here, evaluate functions and create a T-chart to show your work or to show your answers, okay? So the big idea here is the following. Last week we talked about a function machine. We've been talking about this idea of a function, and it's going to be a normal idea in math, okay? So a function machine is like, let's just pretend this is like my machine, right? If I put in ingredients for like tortillas, salsa, and meat, like whatever meat, what should come out? Taco, right? Right? It would function correctly if a taco came out, right? Now what happens if I get a taco and a gorilla? Okay? Is it functioning correctly? No, it's not functioning correctly. It's kind of weird, actually, right? I wouldn't even eat the taco if a gorilla came out. Okay? Alright, so it would be incorrect to say that it's a function, okay? So, but in math, we use the same idea. Let's say there was a math function, you're programming a computer, right? And you're saying, whenever a number comes into this, I want you to do the following with it. So, let's say I put in a number 3, and let's say the computer's programmed to say, okay, whenever you put a number 3 into this machine, it's going to go through here. It's going to get 3x plus 2. So it's going to be multiplied by 3, and then 2 is going to be added to it. Okay, so what should my answer be if I'm taking 3 and I'm going to put it through this function? What should come out of the other end? What? I heard someone say it? 11, right? So what's 3 times 3? 9 plus 2? 11, that's right. Okay? So that's the big idea of what we're doing today. Okay? So there's more than one ingredient for these. I can use as many ingredients as I want for this example at least. And that's our domain, and the range would be what's popping out. So the next thing I want to talk to you about some vocabulary. Evaluate. Whenever we see the word evaluate, I want you to think of this Pemdas, or orders of operations automatically. Okay? Evaluate means Pemdas, and then whenever you see the word solve, I want you to think SADMAP, okay, which is the opposite. But today we are doing evaluate. That's all we're doing today. Okay, so let's read what the definition for evaluate means, starting with 2. Ready? And begin. To find an answer for the given function with the given domain. Okay? So we're going to find an answer for the given function with the given domain. Meaning, if I put this number in, what's the answer going to be? Okay, we use PEMDAS. Function notation. The big idea is that it's a math machine. And when we see it in math, we're going to see this thing called f parentheses x. Eyes up here. F parentheses x. So f of x, we read this f parentheses x as f of x. Okay, so let's read this as f of x. Let's all say f of x. F of x. Good. Okay, so that's what we would say in math, and it's really important we know how to read it because a lot of times kids see this and they're like, I don't know what this means. That's f of x. Okay, right here. Good. Okay. If you're on the video, you have steps right here. Please pause the video here and write the steps down. All right. Time for the classwork. Here we go. Okay, so number 1. I'm going to show you how to do numbers 1 and 2, and then 3 and 4 we'll do together. Okay? So eyes up here, pencils down. So number 1, we have a domain, or the inputs or our ingredients are -3, 1, and 4. So this is the name of our function. We got f of x is equal to -3x plus 5. So how does this work? Eyes up here, eyes up here. I want to make sure we got this. So whenever I see an x, I want to replace it with my ingredients. Okay, so I'm going to put the first ingredient in. So instead of f of x, I'm going to say, well, what happens if I put in -3? Okay, y'all see I took f of x instead of x, I put in -3. So I want to see what this math machine or function would do if we put in -3. So then I would rewrite this. Take the original problem. Instead of x, I'm going to replace it or substitute it with -3. So I'm going to need to put a different color so you can see what I'm doing here. So I'm changing or substituting x with -3. And then we bring down the rest of the problem. And then I'm using PEMDAS, okay? I'm thinking -3 times -3 is 9, right? Bring down the rest of the problem. 9 plus 5 is 14. So that means in my function, if I have a negative 3, f of negative 3 would equal to 14. Okay? Input of 3, negative 3, output of 14. Okay? Make sense so far? Then I'm going to go to the next one. We got 1. F of 1. Okay? F of 1, I'm going to input. I'm going to bring down the original problem, 3x plus 5, but instead of x, I'm going to put in 1 this time. So 3 times 1 plus 5. 3 times 1 is 3. And then, I'm sorry about that. 3 times 1 is 3. And then 3 plus, I'm sorry, negative 3 times 1 is negative 3. 3 plus 5 is 2. Okay, so that's the first one. Or the second one. First and second one are here. Then we got f of 4. Putting in f of 4. Okay, so instead of x, I'm going to put in 4. So I'm going to bring down the original problem. We got negative 3 times 4 plus 5. Okay, so negative 3 times 4 is negative 12. Negative 12 plus 5 is negative 7. You see that? So that means f of 4 is equal to negative 7. Okay, that's my last input and output. I could do more ingredients if I wanted to. Don't worry about that. Okay, I could put in more ingredients if I wanted to, right? Couldn't I put in 0? Couldn't I put in 100? Yeah, I could put in anything. But I want us to focus on these 3 for this example. So then when we're done, we're going to make a t-chart. It's like a table. So we're going to make a t-chart, and I'm going to start with f of x and x. We're going to put x on the top left, and then we're going to put our ingredients in here in descending order, negative 3, 1, and 4, like last week. And what was my output? When I put in negative 3, what did I get? 14. Or if I put in 1, I got 2. If I put in 4, I got negative 7. You see that? And that's it. That's number 1. Okay? So this t-chart or table will get bigger if we put more ingredients in. But for today's, we're going to learn the basics. We're going to just use these, okay? Questions on number 1? Let me try, or I'm going to show you how to do number 2. Let's watch one more time. Number 2 is down here. So we got a domain of negative 3, negative 2, and 5 right here. Okay, so, and then we got our function. This time it's not f of x, but f of g. F of g. So that means whenever I put in a letter for g, or a number for g, I'm going to replace anything that says g with that number. So the first one we're going to do is f of negative 3. So we're saying f of negative 3 is equal to 2 times g, which in this case we're going to put negative 3, replace it with negative 3, and then we're going to subtract 3 from that. Okay? So 2 times negative 3 is negative 6. Negative 6 minus 3 is negative 9. Okay, so that means when I have an input of negative 3, I get an output of negative 9. I'm going to do the next one, which is negative 2. Okay, so f of negative 2. And I'm going to rewrite this original problem, 2g minus 3, except I'm going to replace g with negative 2. So it's going to be 2 times negative 2 minus 3. 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. Okay, so that means f of negative 2 is negative 7. Last one, we're going to put in 5. When I put 5 in, I got 2 times 5 minus 3. It's going to be positive 7. Then I'm going to take my inputs and outputs and create a t-chart just like the last one. So I'm putting in g and then f of g, so all my ingredients go under g. Outputs, so I have a negative 3, I said I had a negative 9. Negative 2 is negative 7, and then 5 is positive 7, and that's it. Make sense? Okay, that's what we're doing today. These could be ordered pairs. One day we're going to graph them, okay? We're going to graph these. Couldn't I graph negative 3, 14, 1, 2, and 4, negative 7? Yes? Yeah, we could do that. So we're building up to graphs really soon. Super exciting, okay? Questions on numbers 1 or 2? No? Okay, good. So let's have you kids talk about, let's have 1s are teaching the rest of the group about number 1, and then 2s are teaching the rest of the group about number 2, and then write these down. Ready, set, go. We're going to write f of h down, so, but instead of h, what is our first ingredient going to be on number 3? Negative 4. So we're going to write f of negative 4 here, and then we're going to rewrite our equation, but our expression. We got 2h minus 3 Instead of h, what am I going to be putting in? -4. So we got 2 times -4 is, and then subtracting 3. So let me help you out with this one. What's 2 times -4?
-8.
Good. -8 minus 3.
-5.
-5. -11. Which one is it? Talk to your groups about it. What's the answer for this one when we evaluate it? What is it, everyone?
-11.
Good. -11. Thank you. Awesome. Okay, so we put -11 down. Okay, finish up the problem for me now. I would like you to work in your groups. If you need to help each other out with this, that's fine. I want you to end off with a T-chart like we have on numbers 1 and 2. So I'll be walking around. I'll give you about a minute and a half, okay? Go. All right, so that's the answer to number 3. Number 4, here we go. We got the domain. We want to test is -2, -1, 0, and 1. This one's a little weird. I'm going to start this one off for you, and then you'll finish it, okay? So this one says f of g is equal to g squared plus 1. So I'm going to put f of -2, okay? And then our g squared, we're going to put in not g squared, but -2 squared. And you see how I put it into its own parentheses? Okay, so now we have to think about this. Let me work this one out. What's -2 squared? Meaning, like, what's -2 times -2? 4.
4.
Positive or -4?
Positive.
Good. Just want to make sure we got that. And then what's positive 4 plus 1? 5. So then our f of -2 is going to be 5, okay? I should say -2, okay? All right, finish up this problem, or the rest of the domain. Okay, good. So the top left of it's going to be g, right? What's on the top right? F of g. Okay, and then what are the numbers that are on the left side? Good, so when we had -2, we had an output of 5. -1, what's my output if I put -1 in?
2.
Good. Okay, what's my output if I have a 0?
1.
Good. What happens if I have an output of 1?
2.
2, right? So you notice that it's repeating itself. What would happen if I have an output of 2? What would my output be? If I have an input of 2? What? 5 again, right? Does anyone see a pattern with this one?
Yes.
Yeah. Talk to your group and tell them what the pattern is. Go.
It's 5.
Okay, continuing on here. Let's do one more here. One more. Last one, okay, and then we'll be done. Last one, because we are getting it. So we have f of n is equal to n squared plus 5n. This one's a little bit harder, but I think we could do it. And instead of, we're going to use f of 9, but I want you to also find two other ones. I want you to find f of 0 and f of 5, okay? And I want you to write your answers in descending order. So what I mean by that is, like, you're going to write your T-chart like this, where you have 0, 5, and 9, okay? On the left. Work this one out. It's bigger numbers, but we can do this, okay? This one's like number 4. And just to get you started, you know, if you're going to do f of 9, you should put in 9 squared plus 5 times 9, right? This is to get you started. Some people have trouble getting started because they just do. Okay, we get a 0, right? Because 0 squared is 0. 5 times 0 is 0, so 0 plus 0 is 0. What happens if I put in a 9? I get a 12, right? What happens if I put in a 5?
126.
Oh, 126. Just making sure you're awake. Okay. What happens if I get a 5? 50, good, and then 0 is 0, right? That's it. Okay. All right. So that concludes the lesson.